Dilution is the addition of solvent which decreases the concentration of the solute in the solution. So sa dilution, para lang tayo nagtitimpla ng juice. For example, we have a glass of orange juice. Yung orange juice natin ay isang concentration solution. So concentration is the removal of solvent. Yun yung nagpapataas ang concentration sa isang solute sa solution. And yung orange juice natin is lower volume lang and higher concentration. Lower volume because wala pa tayo na-add na solvent na kaya siya higher concentration. Dahil small amount lang siya, which is sabihin na natin matamis siya and kulang siya sa water. So, anong mangyayari kapag nag-add na tayo ng solvent, which is yung water? Pag nag-add na tayo ng water, magiging dilution solution na siya. Dilution is the addition of solvent, which is yung water, na nagpapababa sa concentration ng isang solute sa solution, which is yung juice. So, magiging higher volume na siya and lower concentration. We can add water to the concentrated orange juice to dilute it until it reaches a concentration that will be pleasant to drink.
Factors affecting solubility. First, what is solubility? The maximum amount of a substance that will dissolve in a given amount of solvent at a specified. First, temperature. Basically, solubility increases with temperature. Example, sugar will dissolve easily in a warm water. Second, polarity. In most cases, solutes dissolve in solvents that have a similar polarity. Example, water is a polar solvent and it will dissolve salts and other polar molecules, but non-polar molecules like oil. Next, molecular size. The larger the size of the molecules of the solute are, the larger the molecular weight and their size. It is for solvent molecules to surround bigger molecules. Next, stirring increases the speed of dissolving. There are three types of solution, and the first is saturated solution. A saturated solution is one in which no more solute can be dissolved in a given amount of solvent at a given temperature. Some of the salt is still dissolving in the solvent, while some of the dissolved solute is crystallizing. Example, salt and water. Second, unsaturated solution. A solution that contains less than the maximum amount of solute that is capable of being dissolved. Example, salt and 1 liter of water. Third, supersaturated solution. Supersaturation occurs with a solution when the concentration of the solute exceeds the concentration specified by the value of solubility at equilibrium. When a seed crystal is added to the solution, a supersaturated solution can recrystallize.
Hi, good day everyone. I'm Vanessa F. Manibog, and right now we're going to tackle about the general chemistry is grade 12. And my topic is all about the factors affecting solubility in a solvent. Let's proceed. Right here, we have three objectives. Number one, which is the student should be able to define and give examples of mixtures in everyday life. And number two, the student should be able to differentiate between nature of solute, temperature, and glass pressure. So last, students should be able to make comparisons between solubility, solvent, and solute. So before we proceed on our topic on the three factors affecting solubility in a solvent, right here we're going to define the terminologies of solute, solvent, and solubility. Number one, what is solute? So when we say solute, a solute is substance that dissolves in another substance. It is a component in a solution present in a lesser amount. They are called major components. Say solute, or let's explain on Tagalog para mas maintindihan. When we say solute, ito yung substance na nadidissolve or natutunaw sa solvent. Ito yung tinatawag natin solute, or mas konti yung component ng solute pag ilalagay natin sa solvent. So, that's solute. An example of solute Right here, I have sugar, which is we are going to dissolve this on solvent. So this is an example of solute. Or we have an example here, which is solute, salt. Salt are gonna dissolve on water. So that's an example of solute. And right now, we are on solvent. When we say solvent, a solvent is a substance that dissolves in a solute. It is usually a liquid. When we say solvent, ito yung substance na siya yung tutulong na ma-dissolve yung solute. When we say solvent kasi, usually they are water. Example, here, mineral water. So that's an example of solvent. And last, we are going to define the solubility. When we say solubility, solubility is the ability to be dissolved, especially in water. An example right here, we have the salt and we're going to dissolve it on water. So what happened? This is the final result of dissolving of salt in water. So when we say solubility, ito na yung final result or ito na yung ability or ito yung mangyayaring solution na once na na-dissolve na yung solute sa solvent. So that's solubility. And I'm here to qualify. Trivia lang. Pag sinabi natin solution, ito yung final result na nakikita natin sa solubility. When we say naman solubility, ito yung ability o ito na yung nakita lang natin na result kung paano mag-dissolve yung solid sa solvent. When we say solution, yun yung final. When we say solubility, yun yung ability ng pagtunaw ng solid sa solvent. Gets? Right now, we're going to tackle about the three factors affecting solubility in a solvent. Number one, nature of solute and solvent. So, dito daw nakadepende daw yung nature ng solute or ng solvent sa kanilang pag-dissolve. When we say nature of the solute and solvent, the solubility of solute in a solvent depends on the nature of both. An example here, I'm holding an solute, which is oil, and I'm holding the solvent, which is water. So we are going to mix them. I'm going to dissolve the oil on water. Oh no! Oh no! Oh my God, did you see that? We're going to mix them. Shing, shing, shing. Oh no! They are not compatible. So did you see the result of mixture of oil and water? So this is an example of nature of solute and solvent. So the nature of oil is non-polar, while the nature of water is polar. So they are not compatible to each other because non-polar and polar are on mixture. So as we see on here, hindi nag-mix, which is yung oil nasa ibabaw lang and yung solvent na water ay nasa ilalim lang. So hindi sila talaga mag-mix kasi non-polar yung oil, which is yung water naman ay polar. I have another example here of nature of solute and solvent. Right now, I'm holding a solute, which is the sugar, and the solvent, which is the water. We are going to dissolve the sugar on water, or we are going to mixture the solute on a solvent. We are going to stir them. So what happened? Sugar are dissolved on water. This is an example of polar compound and a polar compound which is compatible to dissolve. Or what we call dissolves like dissolves. Another example here, I have salt, which is the solute, and I have water, which is the solvent. We're going to mix them. We are going to stir them. Oh, did you see that? Did you see the solubility of salt on solvent? They are compatible. Why? Because salt is ionic compound. And while the water is polar compound. Did you see the solubility of salt on water? When we say salt, that is ionic compound. When we say water, that is polar compound. So they are compatible to each other. Why? Because of ion dipole dispersion. When we say ion dipole dispersion, the polar and the ion compound is attracted to each other so that they are compatible when we mix them. An example is the water and the salt. So, let's proceed on temperature. When we say temperature, raising the temperature will increase the solubility of solute in the solvent. So, I have an example here. We're going to test the solute, which is the coffee, on different nature or different temperature of solvent. So, as we see here, this is the hot water and this is the cold water. So, ano yung mas mabilis matunaw dito? Yung cold water or yung nasa hot water? Saan mas mabilis matunaw yung solid natin or yung coffee natin? Saan mas mabilis siya mag-dissolve? Sa cold water or sa hot water? Diba? Mas mabilis siya matunaw sa hot water. Unlike sa cold water. As we see, here's the result of hot and cold water based on their temperature. This is the result of dissolving of coffee based on the temperature of solvent, which is the water. But here I have another facts or trivia. So here, do you know the difference or you can differentiate between the endothermic or exothermic? When we say endothermic, an endothermic process absorbs heat and cools the surroundings. An example, ice cube. Di ba kakabili mo lang ng ice cube, dala-dala mo siya. You put out there, then ano nangyayari sa ice cube? Di ba matutunaw siya? Why? Because na-absorb na yung heat, which is yung energy ng or yung lamig ng ice cube o yung energy ng ice cube na re-release. Kaya natutunaw yung ice cube dahil ina-absorb niya yung heat imbis na i-release niya yung energy niya. So, number 2, exothermic. When we say exothermic, an exothermic process releases heat, causing the temperature of the immediate surroundings to rise. An example, pag nagka-camp tayo, di ba yung nagka-campfire, gumagawa tayo ng campfire. Ano nangyayari kapag gumawa tayo ng campfire sa camp natin? Di ba? Parang iinit yung paligid natin. Example, yung parang kayo magkakaibigan, di ba? Mag-ano kayo ng marshmallow. Tapos, yung gumawa kayo ng malaking campfire, di ba? Parang mainit-init na yung paligid nyo. Why? Because an exothermic process, nagre-release siya ng energy niya imbis na mag-absorb. So, that's the difference between an endothermic and exothermic. When we say endothermic, nagre-release yung energy niya. When we say endothermic, yung energy niya na-absorb. When we say exothermic, yung energy niya nagre-release. So, that's the difference between an exothermic and endothermic. So, let's proceed on last pressure. And last pressure, ano nga muna yung pressure? When we say pressure, pressure has no effect in the solubility of solids and liquids, but has a strong on the solubility of gases. So, dito, wala naman siyang pinakamalaking effect or impact when it comes sa solid or liquid, unlike dun sa dalawa kanina na temperature and nature of solid and solvent. When we say pressure, dito na may kinalaman yung dissolve ng gas sa isang component. So I have an example here of an open wine which was I bought from Baguio. So never been opened but been touched. I never been opened the can. So let's open this. I have an example for you. Okay. I have an ano dito. Makikita nyo, wala siyang bubbles, di ba? Why? Because the pressure here is there. High pressure, high solubility. So, yung solubility ng yung CO2 nang nasa loob mismo ng Y, nandito lang siya. Nagdi-dissolve siya dito sa component ng Y. Kasi never been open. Nandito lang yung pressure. Higher pressure, higher solubility. But once I open this, makikita nyo, ayan, nagbababol na siya. Ayan, nagbababol na. Ayan, nakikita nyo na. Hala, tingnan makita. Shit, nagbababol na. Diba, nakikita nyo, nagbababol na. Once na in-open ko, why? Because the lower the pressure, the lower the solubility is. Why? Kasi yung CO2 niya, yung carbon dioxide sugarness niya, lumabas. Kasi in-open ko na yung kakabukas lang na wine eh. So, magbabubble siya. Hindi na siya magdi-dissolve dito kasi lumabas na yung solvent niya na pressure o yung CO2. Kaya nagbabubble siya. So, the lower the solubility is, the lower the pressure is, the lower the solubility. So, that's the pressure on solute and solvent. Do you understand? So, thank you for listening on my report and I hope you understand it. Even though I already talk too much and I can't understand even myself. Thank you. Hope you have learned even a small thing. And if you more have question, please search it on Google instead. Bye-bye.
You wanna fall in love? Would you get me spinning? Wouldn't it be awesome?
Good day. Ako si Roble. Tamad ako pero may pangarap ako. So, ang topic ko ngayon is colligative properties of solution. So, colligative properties are the properties that depend ideally only on the number of solute particles in solution and not on the nature of solute particle. Basta pag colligative properties, we are actually focused not on the nature, rather on the quantity or number of solute. Natin tatandaan kapag ang usapin po ay patungkol sa colligative properties, ang usapin ay tumutukoy sa bilang ng solute at hindi sa nature ng solute. So, ang colligative properties are include vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So, ang solution are also can be classified as electrolytes or non-electrolytes based on the dissolution of solute in the solvent. Electrolyte. An electrolyte solution contains solute that dissociate into ions when dissolved and are able to conduct electricity. And a non-electrolyte solution contains solute that do not dissociate into ions when dissolved and therefore do not conduct electricity. So, ang difference sa dalawa, ang electrolyte is ionically bonded substances act as electrolyte. So, ang non-electrolyte naman is covalently bonded compound in which no ions are represented and are commonly non-electrolyte. So, ang ibig sabihin lang po, ang mga electrolyte or yung mga ionically compound, kapag po sila ay hinahalo o dinagdag para gawing solution, nagbe-breakdown sila into ion. Habang ang mga non-electrolyte or covalently compound, wala itong ion, kaya kung ito ay ihahalo or gawing solution, hindi po sila nagbe-breakdown to form ion. So remember po, ang ions can conduct electricity. Kaya po yung electrolyte can conduct electricity habang non-electrolyte cannot conduct because wala silang ions. Kaya yun po yung difference sa dalawa.
Okay, now, let's talk about freezing point depression. First of all, what is freezing point depression? Freezing point depression is a lower vapor pressure of a solution compared to a pure solvent affects the freezing point of the solution. The freezing point of a solution is lower than a pure solvent. So in short, ang freezing point depression ay ang pagbabago ng temperature o ang pagbaba ng freezing point ng isang solution. The greater the number of the solute particles, the lower its freezing point because the solutes interferes with the crystallization of the solvent and thus need to be cooled down to a lower temperature to achieve a solid. Nakadepende din sa solute, sa amount ng solute, ang pagbabago ng freezing point ng solution. Mas madaming solute, mas mababang freezing point ang na magkakaroon ang solution. Okay, ang normal na tubig ay may freezing point na 0 degree Celsius. Pero kapag nag-add tayo or naglagay tayo ng salt sa pure water, ang freezing point nito ay bababa dahil sa kagagawan ng salt. Okay, now let's talk about paano nangyari yun. So, hydrogen bond. Meron ako dito hydrogen bond ng water and hydrogen bond ng ice. Hexagon yan, which is a characteristic structure of ice. Okay? Pero kapag naglagay tayo ng salt sa process ng water, may interrupt yung process order or yung solute. Dahil doon, mas maraming energy ang dapat mailabas na nagre-result sa mas mababang freezing point ang kailangan para ma-freeze. Okay, example. Bakit ang isang vodka ay hindi nag-freeze sa loob ng isang ref? Okay, dahil ang vodka ay may solute na ethanol na hindi kaya i-freeze ng isang ordinaryong ref dahil ang ethanol ay may freezing point na negative 114 degrees Celsius. Hindi ito kaya i-freeze ng isang ordinaryong ref dahil ang ordinaryong ref ay mayroon lamang 17 degrees Celsius. Pero maaari pa rin ma-freeze ang isang vodka kapag gagamit tayo ng isang hindi ordinaryong ref. So that's the end of my lesson, freezing point depression.
What is boiling point elevation? Boiling point elevation refers to the increase in the boiling point of a solvent upon the addition of a solute. When a non-volatile solute is added to a solvent, the resulting solution has a higher boiling point than that of the pure solvent. For example, the boiling point of a solution, sodium chloride, or salt, in short, and water is greater than that of pure water. Boiling point elevation is a colligative property of matter. It is dependent on the solute to solvent ratio, but not on the solute's identity. This implies that the elevation in the boiling point of a solution depends on the amount of solute added to it. The greater the concentration of solute in the solution, the greater the boiling point elevation. That is all. Thank you.